Hello, everyone. Let's get started. Please download Laboratory 24 and this hypothesis lab data CSV file from Blackboard. Today we are going to learn the third class of hypothesis testing. So, all right. So first, please run the first script to identify your host name, username, and current information. And next one, please input your name, a number, title, and date. Okay. And next one, let's work on another example. First, we need to import necessary packages. So I think these three lines of codes are always our first assignment, right? Import NumPy, import pandas, import matplotlib. Okay. And after that, please use pandas to import or to import a CSV file, right? CSV and hypothesis. Let's have a look, right? So in this hypothesis lab data, we have like 100 rows, right? Data one, dataset one, dataset two, and for the first one, the mean value, and the second one would be the standard deviation, but not standard. So we can figure out the mean value would be different, right? So for the first dataset, you see it is much smaller than the content of the dataset two, right? So after we import the content of this hypothesis lab data, we need to do the analysis, right? So we need to check out the set one, set two. We use the variable to store them, set one, set two, and print out. And after that, we use the describe function to print out the mean value, standard deviation, minimum and maximum. And second one, set two, it would be, it's the same, right? It's similar. So standard deviation, minimum and maximum, right? And the mean value, the first one is 48, and then the second one would be 508. It's much larger, and the standard deviation is different. This one is about 15, and it's 47. So it's very large. It's largely different. Yeah. So, but in today's class, we need to do the visualization. We want to show you how to actually how to use a histogram to show how different or how similar of two datasets. Okay, so that's why here we need to plot a histograms. We said the bin number would be 10. And first we need to set a figure, right? And get the data, raw data, and use dataset one dot plot histograms. Here we don't want the grid, and set the bin number, set the bar width, color, and the edge color, title, X label, Y label, and after that we set the grid line again. So it is about the Y axis, and the second color would be yellow. See here. Alpha means the transparency about the color, about the line, yellow line, right? So you see here, the yellow one is about Y axis. So check out. So first thing, there are 10 bins, right? In the figure, 10 bins. And we know the mean value is about 48 here, 48. So it's the majority of the data, this distribution of data are located in the middle 4 bars, right? So, but the number is quite smaller. X-axis is value, Y-axis is accounts, right? It's about the first histogram of dataset 1, right? Okay, so any questions so far? Okay, next one is about the second dataset. So we set the similar ones. Actually, I think you need to copy this one and paste for paste it as the first line. You can set the figure size, right? And it's very, very similar. Only difference is we use different data set 2, and the histograms, the bin number would be 10. So please change the figure size, okay? Use 10 and 5, the ratio, and the mean value, and also yellow line for y-axis. In this example, the like the mean value would be 508 is here, right? So it is the largest, this bar is largest, and so with the distribution is different, the mean value is different, and the standard deviation is different, right? If we want to compare them together, compare these two datasets, we need to like create a new figure to include them all, right? So that's why here we want to draw them together. So in this figure, in this one, we need to use a new code, right? So we set a figure and x means the subplot, right? And after that, we set the data, and density is false. We set on density, and then set is it as a subplot, title bins, and set y label and grade, right? So in this one, for this one, x grade, y only y grade, right? So if you don't want that, you can use this way. So there's no grade, but we want to have some grid lines, okay? Okay, so it's about how to draw this figure in the, how to draw the two data set in the same figure, okay? The bins would be 40. And because the mean value is largely different for set 1, the mean value is here, it's like 48, and the second one is about 500. So they're quite different, and they are very far, right? Okay, so any questions, or do you have any errors when you run the cells? Okay. Okay, next one is Seaborn package. It's another way to plotting the histograms, but perhaps you need to install it first. Install Seaborn. You need to install it first. All right. Let me show you, and perhaps you need to wait maybe for like 5 or 6 or 10 seconds, because I have already installed this package. So here is the requirement already satisfied, and I already download, right? But for you, if you have error about the Seaborn, you need to install it first, all right? And after that, we need to use the functions from Seaborn, and it's similar, right? If you check the results from here, check the codes from here, it's a similar figure x and the subplot and the histograms plot, histogram plot, data set 1, and the color is navy, and KDE. I will show you what is KDE. AX means it is a subplot, and the KDE dark color show it. So in this one, we can check the results. It's different, right? So it contains not only the bar of the bins, and it also have a curve line to show the like the difference between the different bins, the distribution, right? So that's why here is a little bit, it's better, right? It's a better one, right? And a little bit different is here you see it's a little, for this one and this one, it's not exactly the same, right? So because actually in this one we set it at 10 bins, right? 10 bins, and this one we didn't set the bin number, so it divides the the distribution into uneven bin number. So that's why here this is less than 25, but here you see the largest height is over 35, but this one is smaller than 25, so it's more even, it's better. And for KDE, it's an important terminology, and you will learn it in the following lectures. And for now, you need to know, as it's a fundamental data smoothing problem. It's actually a probability functionality. It's based on the data sample, and you just need to know it's a smoothing technique to make it look better. Okay, and it's also a density function to estimate the probability. Okay, it's about the KDE. Okay, so any questions, or do you have any errors when you run the cell? Okay, and next one, because we have already installed the Seaborn, we can draw the figures again. So Seaborn, histogram plot, set1, Navy, KDE, right? So it looks better, right? So it has some bin number. There are only like 8 bins, not 10 bins, and the curve is very smooth, right? And it's about the data set 1, and next one is another way to draw the data set 1, so it's similar. And next one is about to draw the data set 1 and data set 2 in the same figure. And the last one is draw data set 2. Okay, so the color would be orange, I think. Orange one is better, I think. So this is an example to show you how to draw plot histograms with a Seaborn package. I think it's better than the histogram function in Matplotlib, right? So, but it depends on you. You can choose either one if you want, right? So, but I think that this figure looks better if you choose the Seaborn. Okay. Yeah. Next one is about another terminology. ECDF is also a distribution function. This one is a function jumped up by 1 divided by 10 at each of the n data points. So actually, it's another technique to construct a data into another normal distribution data. So you will also learn it from the following lectures. Yeah. So today we just need to use it. Okay. In the previous labs, we extract dataset 1 and dataset 2 and draw the 2 figures, right? But later we will generate two other figures, but based on dataset 1, dataset 2, we call it dataset 1S and the dataset 2S. So first thing, we need to get the mean value and standard deviation again. So set 1, mean value, standard deviation. And after that, we use the NumPy random normal to create another normal distribution data. But it is based on the mean value and the standard deviation of set 1. Or second one is set 2. It's also a normal distribution, right? Normal distribution here. And for now, we have 4 different datasets, right? And after that, we can draw them together. First thing, we can draw set 1 samples and set 2 samples. This one, right? These 2. Let's see here. This figure is very, very similar with this figure, right? Because they share, but it's different because in this one we draw sample 1S. It means sample 1 samples and set 2 samples. It's not set 1 and set 2. Okay, so we can draw these 4 DSS together. So as you see, we have 4 DSS in this figure. Set 1, set 1S, set 2, set 2S, right? But we can check this is very similar. Set 1 and set 1S because set 1S is generated by you, and you use the mean value and standard deviation of set 1. So that's why here their mean value is the same, exactly the same, and their standard deviation is the same. So that's why here the distribution is similar, and the same for set 2 and set 2S. The distribution is very similar. You can also use box plots to compare these 4 datasets and discuss the differences. So in this one, in the second one, in this figure, the mean value is the same, right? And the standard deviation is similar, but because it's only a sample, only 100 samples, it's not exactly the same as set 1. So that's why here the distribution is similar, but not exactly the same. For set 2, it's the same, is similar, right? So the mean value would be the same. Distribution is a little bit different. Yeah. So, okay. So, any questions? Any questions so far, or do you have any errors? Okay. Okay. That's today's exercise. So the first pair and the second pair look similar, while the 2 pairs look different, right? The question is, how can we know if 2 sets are truly different or not? So that's also the key point of today's class. So how to determine if 2 datasets are similar or different. Set 1 and set 2, they are similar because they share the same mean value and the standard deviation. And set 2 and set 2S, they share the same standard deviation and the mean value, right? That's why they are similar. And for set 1 and set 2, they are quite different because they are different distributions. They have different mean value, different standard deviations, different maximum number, right? So you can answer this question by the mathematical words, or you can show it, you can explain it with the figures. So for instance, when you draw them together, it's different. And from the box plot, the distribution is different. And from the mathematical perspective, the mean value and the standard deviation, they are different. Okay, so, all right, so it's today's exercise. Yeah, so that's all I want to share today. And if you don't have any other questions, please leave the meeting and have a good lunch. Have a nice day. Thank you, guys. Yes. Actually, when you create the set 1 and set 2, you just use the mean value and standard deviation from set 1 and set 2. So that's why they are same, right? Yeah, does that make sense? No, they are not the same because they are randomly selected. So they are not the same. They are just similar. You can find it from here. So they are not exactly the same. Right? So this one is much larger. You see, the samples are different, but they share the same distribution pattern. That's why we call it similar, not exactly the same. Okay. No, they are similar because they have the same mean value and the standard deviation, the same mean value and the standard deviation, but they are different distributions. So that's why they are similar, but not the same. Yeah. Okay, yeah. Okay, so I'll stop here. Thank you.